Hi, good day everyone. We are from PT1 Major in Economics, and today welcome to our blog. Before we start, let us introduce ourselves first. I am Aira&Mira.
Sheila May Mutol.
And I am Judeline Monte.
And welcome to the world of math. Today, we'll be turning tables and convince at least all of you hate math that it's quite amusing. We will learn together the nature number by Ian Stewart, Chapter 1, The Natural Order. But you may ask, who is Ian Stewart? Well, Ian Nicholas Stewart is a mathematician and prolific author, having written over 40 books on all aspects of maths, as well as publishing several guides to the maths used in Terry Pratchett's The School books, writing half a dozen textbooks for students, and co-authoring a couple of science fiction novels. Stewart writes in a marvelously clear style, but more importantly, he is interesting. He sees the world in an interesting way, in a mathematical way, and managed to convey the wonder and strangeness and powerful insights which seeing the world in terms of patterns and shapes, numbers, and math. Ian Stewart wrote the nature's number because he wants to help us see the world as a mathematician sees it, full of clues and information which can lead us to a deeper and deeper appreciation of the patterns and harmonies all around us.
Now, we will give you the summary in nature number in chapter 1 called The Natural Order. Based on that, the first sight of these words would tell us that there is indeed a process that we believe is repetitive in nature. Ian Stewart stated in the last part of the prologue, I am going to take you sightseeing in that mathematical universe. I am going to try to equip you with a mathematician's eye, and by doing so, I shall do my best to change the way you view your own world. Do you think you made it possible? There's no other way of finding that out unless we indulge ourselves in his words. What do you think, Miss Judeline?
You're right, Sheila. Let's indulge ourselves in seeing the world with a mathematician's eye through his words. So moving forward, let's go to chapter 1. The title itself sums up the thought of the chapter, where the repetitive process of numbers occurs commonly and obviously in nature. The first line in the chapter really hooks up to the idea that math isn't as boring as we usually perceive it, because in peculiar way, math is the music of reason, the poetry of logical ideas, the magical repetitive scheme of the world that surrounds us. We live in a universe of patterns. Every night, the stars move in circles across the sky. The seasons cycle at yearly intervals. No two snowflakes are ever exactly the same, but they all have six-fold symmetry. Tigers and zebras are covered in patterns of stripes, and leopards and hyenas are covered in pattern of spots. Intricate trains of waves march across the oceans. Very similar trains of sand dunes march across the desert. Colored arcs of light adorn the sky in the form of rainbows, and a bright circular halo sometimes surrounds the moon on winter nights. Spherical drops of water fall from clouds. So for Stewart, we live in a universe full of patterns, and Ian Stewart flooded us with examples of how these patterns exist in reality, wherein such patterns are clues that underlie the rules and regularities that soon define the beauty that we will discover in nature. Many of which are when the stars move in circles across the sky, the season cycles at yearly intervals, trains of waves march across the oceans. Very similar trains of sand dunes march across the desert. Zebras and tigresses are covered in patterns of stripes, while leopards and hyenas are covered in patterns of spots.
The regular nightly motion of the stars is also a clue this time to the fact that the Earth rotates. Waves and dunes are clues to the rules that govern the flow of water, sand, and air. The tiger stripes and the hyena spots attest the mathematical regularities in biological growth, and form rainbows tell us about the scattering of light and indirectly confirm that raindrops are spheres. Lunar halo are clues to the shape of ice crystals. Math isn't just about numbers and equations. Math is the simplest thing around us. Did you notice this includes the moment when you wake up? You see the sun, and after a few hours, the moon rises, then you will go on sleep, and tomorrow, you will wake up again, witnessing the cycle of nature. And so after the daily routine, Stewart presented many points telling us about the regularities of mathematics, which represent the natural order of nature. It might not that ideal for us to perceive the world in a mathematical way, because it might include too much of a process in a systematic way that will soon bore us to analyze the world instead of having an interest in understanding the truth. But Stewart has its way to capture interest by relating to Sherlock Holmes' character. Mathematics is the nature of Sherlock Holmes, and D is the evidence. Sherlock Holmes is top-notch in inferring a situation wherein he can impressively deduce someone's age, occupation, and financial and marital status. Just a few looks at the object that person owned. It's the same for mathematics. Mathematics can look at a single snowflake and deduce the atomic geometry of its crystal. And Dr. Watson, Sherlock Holmes' partner in the series, was not sensitive to such models as him. And hearing his detection will only look through baffled admiration, and this only implies that being confused with the world, we could be more sensitive and open-minded, because through this our appreciation will unveil the truth of nature and see the pattern that nature presents us as evidence that the answer is confusing.
You are totally right. Patterns in nature can actually be evidence that cues the beauty and irregularities of nature. However, this also suggests the idea that an instruction in such patterns stand out. The lines you can see on the screen tells us that for every rule there is an exemption. For instance, to take the four-leaf clover is considered lucky because you rarely see one. Patterns possess a utility as well as beauty. Stand out the desert stands still, but the lion moves against the circling background of stars. A small number of stars that move quite differently beg to be singled out for special attention. You see, these are not just to be admired, but are important clues that help conduct natural processes or things that just happened accidentally around them. Another interesting topic tackles numerology. Stewart states that this only indicates the one most understands the numerical pattern in nature and must distinguish the significant difference from the accidental one, because the concept might be easy but isn't always right. Numerology is the easiest and consequently the most dangerous method for finding patterns. It is easy because anybody can do it, and dangerous for the same reason.
There have been new two types of patterns that mankind has become aware of, and these are fractal and chaos. So what does illustrate the fractal pattern? Fractals are geometric shapes that repeat their structure on ever finer scales. They are created by repeating a simple process over and over in an ongoing feedback loop. A fractal is a never-ending pattern. Geometrically, they exist in between our familiar dimensions. Fractal patterns are extremely familiar since nature is full of fractals, for instance, rivers. This aerial footage from NASA of the Irrawaddy River in Delta in Myanmar is a great example of fractal branching patterns of the river delta ecosystem. Fractals also exist in snowflakes. Even though the fractal is by definition an infinite pattern and cannot be measured, the Cock snowflakes let us see that even though the perimeter of a fractal is infinite, the area is not. As you zoom into the edges of snowflakes, you will find that there are ever new emergence of the pattern, but the size of the snowflake itself doesn't change. This kind of fractal is commonly found in nature when we observe coastline. You can't really get an exact measure of the landmass on Earth because the edges are not smooth and they are rough and variable. The Cock snowflake is a way of showing how the infinite regularities can still be contained with an approximation of the wool driven by recursion. Fractals are images of dynamic system. We have snowflake, we have Fibonacci spirals, seashells, wherein both you can see the geometric shape in the structure. So how about chaos? Chaos is a kind of apparent randomness whose origins are entirely deterministic. Chaos theories state that under certain conditions, ordered regular patterns can be seen to arise out of random erratic and turbulent processes. Take a double pendulum. For example, a double pendulum consists of two physical pendulums. Each is free to rotate 4 to 360 degrees around its pivot. A double pendulum is chaotic system because it is highly sensitive to the initial condition. This means that a tiny change in a starting condition will result in a completely different motion.
Nature patterns are numerical. The simplest mathematical objects are numbers, and the simplest of nature patterns are numerical. A very curious pattern indeed occurs in the petals of flowers in nearly all flowers. The number of petals is one of the numbers that occur in the strange sequences 3, 5, 8, 13, 21, 34, 55, and 89. For instance, lilies have 3 petals, buttercups have 5, delphiniums have 8, marigolds have 13, aster has 21, and most cases have 35, 55, and 89. You don't find any other numbers anything like us. Often there exists a definite pattern to those numbers. Each number is obtained by adding the previous two numbers together. For example, 3 plus 5 is equal to 8, 5 plus 8 is equal to 13, and so on. This pattern with numbers on flower petals is famously known as the Fibonacci number. The number in the Fibonacci sequence was developed by Leonardo Pisano or Leonardo of Pisa.
Nature's patterns are geometrical. In addition to numerical patterns, there are geometric ones. Each tiny dot in the picture is stored and manipulated as a pair of numbers. Bow for the dot is along with the string from right to left and how far it is from the bottom. These two numbers are called the coordinates of the dot. A general shape is a collection of dots and can be represented as the list of pairs of numbers. Until recently, the main shape that appealed to the mathematicians were very simple ones: triangles, squares, pentagons, hexagons, circles, and so on. All of these shapes can be found in nature, although some are far from common.
Other pattern in nature. The flow of fluids provide an inexhaustible supply of natural patterns. There are waves of many different kinds surging toward the beach and parallel rocks, spreading in a V-shape behind a moving fold radiating outward from an underwater earthquake. There are similar patterns in the atmosphere too. The most dramatic is the vast spiral of a hurricane as seen by an orbiting astronaut. There are also wave patterns on land. The most strikingly mathematical landscape on Earth are to be found in the Great Desert or Ocean of the Arabian and Sahara deserts. In addition to patterns of forms, there are patterns of movements in the human walk. The feet strike the ground in a regular rhythm, like left, right, left, right, left, right. When a four-legged creature walks, there is a more complex, equally rhythmic pattern like dog, cat, and etc. The way we walk, writing things down, and even reacting to events are significant variables of our being. With that, it could be understood that patterns are a detailed analysis of human behavior. Every movement of an individual is recorded, analyzed, and studied.
Finally, there is another category of a natural pattern, one that has captured human imagination only very recently, but dramatically this comprises patterns that we have only just learned to recognize, patterns that exist where we thought everything was random and formless. For intake, think about the shape of a cloud. There is a very distinctive pattern to clouds, a kind of symmetry that is closely related to the physics of clouds formation. A large cloud seen from far away and the small clouds blowing up equally possibly have been the other way around. They will be different in the shape, of course, but not in any manner that symmetrically depends on the size.
What a great chapter! To wrap it up, we are indeed living in a universe of patterns. And it doesn't have to be something that the eye should see, because patterns also exist in situations that trigger ripple-like effect which results in a pattern, but most important of all is giving us a different vision of the universe we live in and of our own place in it. We hope you learned something by watching this video. Thank you!